This practical shows how to prepare a pure dry sample of a soluble salt from an insoluble oxide or carbonate using the example of copper-2 oxide and sulfuric acid. The word and symbol equations are copper-2 oxide plus sulfuric acid makes copper-2 sulfate and water, and the balance formula is CuO plus H2SO4 gives CuSO4 plus H2O. The key idea is to react a known excess of the insoluble base with a limited amount of acid so that all the acid is used up and no acid remains in the final crystals. First, pour a measured volume of dilute sulfuric acid into a beaker and warm it gently with a water bath or hot plate to about 50 to 60 degrees Celsius to speed the reaction without boiling. Next, add small spatula portions of powdered copper-2 oxide or carbonate while stirring until the solid stops disappearing and a little black solid remains, showing that the acid has been neutralized. If using a carbonate, expect gentle effervescence of carbon dioxide and continue adding portions until fizzing no longer occurs and a small amount of solid remains unreacted. Allow the mixture to cool slightly and filter it through filter paper in a funnel to remove the excess solid, collecting the clear blue filtrate, which is the solution of copper-2 sulfate. Rinse the residue with a little distilled water to maximize yield, but avoid adding too much water, which would increase the time needed to crystallize. Transfer the filtrate to an evaporating basin and heat it gently to evaporate some water until a drop placed on a cold watch glass forms small crystals at the edge, which shows the solution is saturated. Turn off the heat and leave the hot saturated solution to cool slowly, and then in an ice bath if needed, so that blue copper-2 sulfate crystals grow. Filter the crystals using the vacuum or gravity method. Wash them with a small amount of cold distilled water to remove soluble impurities, and then dry the crystals between folded filter papers or in a warm drying oven. Label the product as copper-2 sulfate with hazard and date, record mass and percentage yield, and explain that the same method works for other soluble salts by choosing a suitable insoluble base and acid.